Rules. My dear friends, we've studied functional groups and we found out a mistake. The mistake was acetic acid has 2 carbons, so the name acid. Acetaldehyde, 2 carbons, acid. And acetone, 3 carbons, still the name was given as acid. So to avoid such mistakes, we came up with IUPAC. So the nomenclature of organic compounds. Nomenclature is the system of naming. The latest and widely accepted system of giving systematic names to organic compound is called as the IUPAC system. Now you might be wondering, sir, you said IUPAC so many times. What is it? IUPAC is an international union of pure and applied chemistry. It is a union of people who decide everything for chemistry, right from the most basic rule to the latest invention, they approve it. All organic compounds are considered as derivatives. Derivatives mean they are obtained from the saturated hydrocarbons called as alkanes. So, terminology used in nomenclature. Remember that every compound is derived from alkanes. So alkanes are the most basic compounds. And from these alkanes, we are going to use different things. Root is the nature of the basic carbon skeleton. It is called the root word. Prefix is the phrase before and suffix is the phrase after. That's it. There is nothing else that you need to study. So root word, prefix and suffix. Now what do you mean by this? Terminology used in nomenclature. Part 2, root indicates the nature and the number of carbon atoms in the basic carbon skeleton. Meaning, if 1 carbon, name is meth, 2 carbon, name is eth, 3 pro, 4 but, 5 pent, 6 hex, 7 hept and 8 is oct. This we've studied already. Yes. So what is and how is the naming done? So the first functional group we are going to speak about is halogen, and a halogen is a prefix. It is not a suffix, it is a prefix. We studied functional group. Functional group changes the properties of compounds, but a halogen does not change a property of a compound that much. So it is not called a functional group, it is called a substituent. And because it is a substituent, it is a prefix. And because it is a prefix, we are going to use the term halo. The term halo as in chloro, as in bromo for bromine, ido for iodine. So the IUPAC name would be haloalkane. And what will be the alk substituted with? Alk will be substituted with the numbers. If 1 is met, 2 is eth, 3 is prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, sometimes known, and 10 dec. The known and dec are just given for you so that you remember it, although it is highly unlikely to ask questions from it. So, let's see the first example. Now there are 2 carbons. So what would be the name? Eth. What? Is there a single bond? Yes. So ethane. Now ethane is the root word. Now what will you do? Spot the chloro. The chloro is a prefix. So what will happen is chloroethane. And there, my dear friends, is the simplest 2 marks you'll ever get. Second, this is a propane because the number of carbon is 3. So 3 meaning prop and single bond meaning ane, and there is a bromo. So bromo is a prefix, bromopropane. So unlike halogens, the rest of the functional groups do not have a prefix. In fact, they have a suffix. Alcohol, that is OH, has the suffix OL. So, what will be the name? It would be alkanol. Not alkanol, but alkanol. Remember, you have to remove the E and add the OL. So, over here, let's see an example. So, the number of carbon is 4. And this 4 carbons, meaning this is a butane. And in this butane, there is a OH ion. So, this OH will be an alcohol. So, butane, add a suffix ol, it turns into butanol. Remove E. Third is the aldehyde, and aldehyde is the suffix al as in aldehyde. So what is going to happen? The suffix will be added after the alkane. So it will turn into alkane alkanal. So alkanal over here, see there are 3 carbons, and 3 carbons meaning propane. And propane, there is a CHO bond right at the end. Over here is a CHO bond. So because of the CHO bond, we are going to term it as al. So propane, remove E, add Al, propanal. Let's see the other examples. Ketone. Ketone suffix is on, and on. Why on? Remember, ketone is a C double bond O. So if you name it, it would be alkane ketone. Add one after alkane. And you can see a C double bond O at the center. That means it's a ketone and it is 4, so it turns into butanone. Next is carboxylic acid, and the suffix given to carboxylic acid is oic acid. And oic acid will be added after alkane, making it alkanoic acid. So let's see this example over here. Carbon is 3, so propanoic acid. So but what about the double bonds and triple bonds? Very simple. Double bond, you will add the suffix ene. So it is simply not alkane, it is a alkene. So we keep it alkene. Like for example, over here there are 5 carbons. Name would be pent, but it is not a ane, it is a ene, making it pentene. There you go, my dear friends. And the last one is triple bond, that is alkyne. And for alkyne, we are going to use the suffix "-ine". So whenever you spot a triple bond, you have to term it as alkyne. So there are 4, so this would be butene. Let's see you with a few more examples in the next module.